So this one is June 2024. So the June 2024 Unit 6, first we'll discuss the electrolytic capacitor shown is used to store the energy. The student connect the electrolytic capacitor into a circuit. State 2 safety precaution that the student should take when connecting and using the circuit. So this is the electrical circuit is there. What are the safety precautions whenever like specifically for the capacitor? Because it is very important to understand that the capacitor terminals which we connect that should be connected properly. Like capacitor is having a positive and a negative terminals as well according to the metric. So we should connect them properly. As you can see here in the figure. So one is a big line, another one is a small line. They are representing a positive. So capacitor also have a positive and negative. So when we connect them, we should be ensured that we connect them properly. The polarity. So for capacitor experiment, the terminals of the capacitor, which like there's a specific one which is connected with a positive, another one connected with a negative. If it's connected other way around, in that case, the capacitor will short circuit, like it will damage the capacitor. The second thing is the supply which we use, like example, the capacitor, we cannot use a very high voltage supply. That can also cause a short circuit or it can damage the capacitor as well. And when the capacitor is charged, like we have to make sure that the capacitor is, once it is charged and then it discharged, so we have to ensure that the capacitor should be fully discharged. Because if the capacitor is charged and you hold the capacitor, you will get an electric shock. So what are the, like make sure the capacitor is completely discharged when handling. And place the capacitor in the right or use correct polarity of the capacitor. How do we discharge the capacitor? As you can see, like example, when it is connected to position 1, it is charged. So when it is connected to position 2, the capacitor will start to discharge. So we want to make sure that all of the charge is removed from the capacitor and then we handle the capacitor. Because here are the safety precautions. So we have to make sure like not a very high voltage applied across the capacitor that will also damage the capacitor. So not high voltage, the terminal, because capacitor can also short circuit. So a very high voltage should not be used. Capacitor should be connected in the right polarity, as well as we have to ensure or make sure the capacitor is fully discharged. Then the student used the switch in position 1 to charge the capacitor and position 2 to discharge. The capacitor discharge and the motor raise a small mass through a height h. Student use a meter rule to measure height. Describe an accurate method of measuring a height. So if you want to measure the height h accurately as possible, so what we should do here, because here we have only single height. Like otherwise, what if there was, or you can also do if you measure two heights, if you measure the two height, like you want to measure this height h. So what you have to make sure the meter rule or the scale should, first thing, it should be vertical. That is important thing. Then the ruler should be placed next to this mass which we want to measure the height from. And for the accurate position, we can use a set square. So we can use a set square, place a meter rule next to the mass, and use a set square to accurately measure this. Or there's also like more important, what we can do, we can measure this total height, and then we measure this height, and what we can do, we can subtract. What is the advantage? Example, let's say this is D and this is A, so D minus A will be equals to H. What is the advantage of doing this method? So it will be more accurate. This will be more accurate method because when we measure the like length twice and then subtract, that will, we can reduce the error, because measuring a longer length will have a lower percentage uncertainty as compared to measuring a shorter length. But won't a measuring a length will be, yeah, in this case, since it is suspended by a string. No, that is, I'm saying you can mention two methods. One is, if you want to measure a height, first what we prefer a measuring a longer length. So a meter rule is placed next to this, and you will use a set square, like you will measure the height till this point, you measure the height till this point, and then subtract. Or directly, this is acceptable even in, usually for measuring a height directly, you will get the height directly here. If they ask us for a suspended length, then the total minus this, I'll get the suspended length. So I can mention, place a meter rule next to the object, next to the mass, and look perpendicular, avoid a parallax error, use a set square, and measure this height. That is what I have to mention. Is it clear? The next is, student repeat the procedure by several times. What is the average? When you read the number, keep one thing in mind. If one of the value appear not in the order, you will ignore that. If all appear in order, you will just add. So they all appear 0.24392421. So add them and divide it by 4. What is the average when you add them? 0.246 plus 0.239 plus 0.243 plus 0.241 and divided by 4. What is the average here? 0.24. But if you see, there are 3 decimal places, so the average should also have 3 decimal places. It is very important, like 3 decimal places are there in the value, so average should also have 3 decimal places. So I should write as 0.242, because if I round it off. Meter. And then uncertainty, percentage uncertainty. For percentage uncertainty, we'll find first the uncertainty. Uncertainty is a maximum minus minimum divided by 2. So what is the maximum value of this order? 0.46 is a maximum. What is the minimum there? 0.29. So maximum is 0.246. Minimum is 0.239 and divided by 2. For a group data, so what is the answer for this? 0.243 minus 0.239 divided by 2. That will give us the uncertainty. But we need the percentage uncertainty. So uncertainty, so it is 0.0035. Okay. 3.5 or 0.0035. And then we need the percentage uncertainty. If we need the percentage uncertainty, it is uncertainty, which is 0.0035 divided by the average value, which was 0.242 into 100. That will give us a percentage uncertainty. 1.46. So 1.46% is a uncertainty in the measurement. So for a group data, that's how we work out the percentage uncertainty. Next is determine the efficiency of electrical motor, the maximum potential difference across the capacitor, and the capacitance is 4,700 microfarad, and the mass is 20 gram. Look what happened when the capacitor discharged, the input is the electrical energy and it lifts a mass up, so the output is a gravitational potential energy. So we will find the electrical energy and we find the gravitational, and to get the efficiency, it will be a gravitational potential energy divided by electrical energy into 100. How to get the gravitational potential energy? It is mgh, mass into gravity into height. That will give us gp. The mass is given in gram, we have to convert into kilogram. So 0.02. Gravity 9.81. Why is the gravitational potential over electrical? As you can see in the question, the energy from the capacitor is used to lift this mass up. As the capacitor discharge, the motor raised this mass up. So final is the gravitational potential. What was the input? The input is the electrical, because motor will take electricity and raise this mass up. So the height, we will take a mean height, which was 0.24, 0.242. That was a mean height. So this will give us a GP, or gravitational potential energy, which is GP is equals to 0.047. So 0.047 joules is a gravitational. What about electrical energy? Whenever a capacitor is there and you have the capacitance and the voltage, energy stored by the capacitor is half Q into V, the charge into voltage, or Q is equals to CV. So it is half C and V square. And this formula, why we'll use this formula? Because we know the capacitance and voltage. So it will be half C into V square. So 1 by 2. C is the capacitance 4,700 micro, so 10 power minus 6. And the voltage of the supply was given 6, so 6 square. How much is the energy supplied by electrical energy supply? 0.0846. So 0.0846. If you need the efficiency, is a useful energy 0.047 divided by input energy 0.0846 into 100. That will give us the efficiency of this capacitor. So this is 55% efficient. 55.5% efficient. Is it clear, this one? Next, we have a question 2. In a question 2, a student investigated the flow of water through a horizontal pipe, as you can see. And the digital pressure gauge is there, and water will flow through the pipe, and how much water enter. The mass of a container is given 0.123 gram, and the mass m of a water leaves the pipe at a time t is given by this formula. Show that the formula gives the unit of n as Newton second meter square. So we have to make n as a subject here. So if n is a subject, this will be pi, density, pressure, radius square t divided by 8 ml. Pi does not have any unit. Density is there. What is the unit of a density? Kilogram per meter cube. Then pressure is there. Newton per meter square. Then radius is there. Meter square. Time is there, second. Then divided by 8 does not have unit. Mass is there, kilogram. Length is their meter. Now we simplify this meter square, meter minus 2 and meter square cancel out each other. Then this kilogram also cancels with kilogram. This meter cube, this is a meter because here length is there. So anything else is left? Kilogram. Yeah, second is left, Newton is left, but this is not making sense. Density of a water is kilogram per meter cube. And this will go up, so this will be -1, not -2. Kilogram per meter is R is okay, okay. This is power 4 is there. I wrote 2. That's why I was confused. So this is power 4. Like what I will do, this is power 4, so this will become m power 4. Now we simplify. Kilogram cancel with kilogram. This is meter -3, -2, -5, -5 plus 4, so this will be -1. There is a Newton as well. There is a second divided by meter. This meter is in numerator. When it will go to like denominator, move to numerator. So this will become Newton, meter -2 and second. Or order. So yes, we will get the same units. Is it clear? The unit for viscosity. Student use a meter rule to measure the L and stopwatch to measure a time. He adjusted the water tap to give a constant flow. Describe a method for measuring accurately N. Your method should include a suitable graph as well. Look, what is the equation for us here in this case? If we rearrange, because we want to find viscosity, and what student is measuring a student measure a length and stop measuring a time, and he adjusted the tap to give a constant flow rate. So flow rate is not changing. And what about the L? L is the distance between the digital pressure gauge. So means this distance can be changed, like we can move this pressure gauge. So the two things which we are changing is L here, and we are measuring T. We are changing, the time will change. So what I can do if I rearrange the equation, so it will be L is equals to pi density pressure R raised to power 4 divided by M 8 and eta, and this will be T. So if I sketch a graph between the y is equals to mx plus c. So if I sketch a graph on y-axis, if I sketch the distance between the two pressure gauge, and t is the time it will take to flow. So the gradient will be this value. And if I need eta, so it's in short, like I will just replace this eta by the gradient. So practically how it should be done, the things which we need for this experiment, because to get the viscosity, when I compare, so the viscosity will be equals to pi rho pressure R raised to power 4 divided by 8 m, and then this will be the gradient. Small m is not the mass here, it's a gradient, because the gradient is equivalent to this. So this will, so to work out the gradient, like I will sketch a graph between the length and the time, and I will work out the gradient, and using a gradient I'll find. But even if I work out the gradient, I need a density of a water. So means we should, and density of a water usually fixed at a constant temperature. So this we consider as a constant. Pi is constant. What about the P? Using the pressure gauge, we can determine this P. What about the radius? So here the water is flowing through a pipe. So this is the internal diameter, because the water is flowing inside, not outside. So for internal diameter, which is the best instrument for measuring an internal diameter, internal radius, we need a vernier caliper. Micrometer is for external diameters. So I cannot say micrometer. So I'll use a vernier caliper, and using the vernier caliper, I'll determine the internal diameter, and diameter divided by 2, I'll get the radius, and then we can square that. M is the mass which is flowing, that is a constant rate is there. So this is also a constant. So first what we will do, the main thing what we have to do is measure the internal diameter using a vernier caliper. And how to improve this? So we can check for zero error and for reduce any systematic error, and change the orientation of the vernier caliper. So we can have an average or a mean result which will reduce the random error. Then to do this experiment, we'll make sure that the pipe is exactly horizontal, and we'll start the timer, like stopwatch. Once the water, like pressure difference should be constant here. P is the pressure difference. Why I'm using a mic? Because a micrometer is having a jaws which can only measure the external diameter. If I want to measure, like example, if I have a glass and this is the inner and the outer wall. So if I want to measure external diameter, I can use a micrometer. Internal micrometer cannot fit for internal diameter. Vernier caliper is having two jaws. One is the lower jaws for external diameter, and the upper jaws are there for internal diameter in a vernier caliper. This can use internal, this for external. But a micrometer is having only two jaws, which can hold the object between the jaws and measure the external diameter only. That's why we cannot mention. So what we will do, we'll record the, like, because what here we are changing. Or even you can use this same equation to get the same result. Like what we can do, instead of changing the distance between the two pressure gauges, what you can do, you can measure the mass of, you can plot a graph between the mass which you collected here and the time. Like in every 30 seconds, how much mass is collected or how much mass is changed. That is the M. So if you plot a graph between M and T, that will also give the same result. Y is equals to mx. So in that case, the gradient will be equals to pi density pressure difference radius power 4 divided by 8 eta L. So in that case, L is constant here. So if I cross multiply like N and M, it will be change switch. So rho is the density constant, P is the pressure difference. We can work out the pressure difference between the two digital pressure gauge, measure that. R is the internal diameter because the water is flowing inside. So that is the internal diameter or internal radius. So we use a vernier caliper. L is the length. By using a meter rule, we can measure the distance between that and plot a graph between M and T. Like plot a graph between M and T, and the gradient will be this value, and the viscosity will be, just rearrange the equation, we'll get the viscosity. Is it clear, this experiment, how it can be done? Then a student use a meter rule to measure a L and a stop. This we did. A mass balance is connected to a digital data logger. A data logger records the mass shown on the table. Two reasons why using a data logger will improve. Look, this is a common question. Whenever two simultaneous reading we have to take, we prefer a use of a data logger because I have to read the mass and I have to read the time interval at the same time. Like two values whenever. So if we don't have a data logger, then how we can improve is by placing the 2 meters together close to each other. In one frame, we can see both of them. Otherwise, if you use a data logger, so it can record the simultaneous reading of the mass and time, and it will give more results in a same time interval. Like it has a greater sampling rate. This is a very common term we use, a greater sampling rate or a higher sampling rate. It means it can collect more data, the data using a data logger, more data can be collected in a same time interval, or more results or set of values can be collected in a same time interval. Because for us, like example, if I keep an interval 5 seconds, it will be very hard to read the values after every 5 seconds. But in a data logger, it will record like even a value in after 1 second or a half second. So more accurate results will be there. The student investigate the rotational oscillation of a mass on a spring using an apparatus. When the mass is displaced through an angle, the mass perform a rotational oscillation. The student use a stopwatch to determine the time period. Describe how student should accurately determine the value of a time period. So how to get the time period? So what student should do? First thing, he should reset the stopwatch, and then he should record the time for like 20 complete oscillations or 30 oscillations. And whenever rotational, and mark the, because when rotational oscillation is there, like this mass is rotating, so there must be, because it's hard to all, it looks symmetry, like very symmetrical. So what is the best way? Whenever rotational is there, when a translationally or oscillation, like oscillation in a linear motion, then we put a mark not on the object, we put mark on the surrounding, like on, so I should have a mean and extreme position. But when object is rotating, it's hard to recognize like when one complete oscillation finished. So I just put a marker on the object. So when I put a marker on the object, then what will happen? Like when this marker goes other side and come back, that is one oscillation, then two. Because when I can see the marker. Otherwise, if I don't put a marker, it will be very difficult to identify that one complete oscillation occurred. So we should put a mark, like reset the stopwatch, put a marker on the object or a tape on the object, and record the time for 20 complete oscillation or rotations, and record the time, divide the time recorded by number of rotations to know that period of rotation. Is it clear? This one, the rotational oscillation. Then a student predicted that the relation between a t and m was formed. A and B are the constant. Explain how the graph for t against m used to determine the value. So look, whenever you see a power and there is no e present, so you will take log both sides. So I will take log t is equals to log a m b. In a log, when two quantities are multiplied, they will be added. So this will be log a plus log mb, or log t is equals to log a. When anything is a power, this is a capital M, so it will be b log m. We are plotting a graph between log t again. So if I rearrange the equation, so this will be log t is equals to b. You don't have to show this all. Even you can write the final equation, then compare with the equation of straight line, which is y is equals to mx plus c. On y-axis, if you have log t, on x-axis, if you have log m, what will be the gradient? The gradient will be equals to b. And what about the y-intercept? The y-intercept will be equals to log a. So what we simply do, we'll plot a graph between log t on y-axis and log m on x-axis, and the gradient will be equivalent to b. Is it clear, this one? Then we have to, student varied the mass and time and plot a graph for log t and opposite grid. So because the log t and m is there, so this will be log t and this will be log m. So just you have to take a value for log t and value for log m. What is log t? 1.46. Log 1.46. log 1.46. 0.16. So 0.16. And what a sorry, 0.16. And what about this one? Log m. It you can make log m first and then log t. Negative 0.698. So it will be negative 0.698. So means m log m was on which axis? The log m was on x axis, and log t was on y axis. So means we will use a negative x axis here. Okay. So we will have the results for the log t. So how the graph should, because we need a negative x-axis, okay? So how to sketch this graph in which the value, like this is a y-axis and this is a x-axis. So how I'll make a negative, so I need a y-axis, I need negative. So I will use this type of graph. Like this will be 0, then -1, -2, -3, and so on, and this will be positive. So the scale of the graph should be like this. Clear? Because you have a negative x-axis, like these are the four quadrants of the graph, and you have a positive y-axis and you have a negative x-axis. So the scale of the graph should appear like this. If you was having a positive y-axis and positive x-axis, scale will be like this. If you have a positive x-axis, negative y-axis, you will have like this. So means this quadrant you will have the graph. So we'll plot the graph accordingly. So when you make the scale, what you will take this as your positive y-axis, and the other one you will take as x-axis, and then write the number. The next is the student measured the plastic. Student made a measurement of a plastic protector. Student used a meter rule, micrometer screw gauge to measure the thickness of the plastic protector. One technique. So if I want to measure the thickness, look, it's a very common question in which they ask this. So how we measure the thickness as accurately as possible? So we should check for zero error to remove any systematic error, and then place the protector between the jaws of a micrometer and measure from different orientation and take a mean to reduce the random error. The next student determined the value of the thickness, which is 1.41 millimeter. Yeah, we will mention one of them. I'm saying two, but will write one of them. Either you mention check for zero error to reduce a systematic error, or you mention place the object between the jaws and measure from different orientation to reduce a random error. Explain why a micrometer is an appropriate instrument. So when we compare the percentage uncertainty, the least count of the micrometer or the resolution is 0.001 millimeter. That is a least count or uncertainty. Least count. What about uncertainty? Uncertainty will be the half of the resolution. So it will be 0.01 divided by 2, so 0.005. So percentage on 0.005 divided by value recorded is 1.41 into 100. So 0.005 times 100 divided by 1.41, which will give us a percentage uncertainty. It will be a very small value. So we'll say the micrometer, like the resolution or the least count is 0.01, and the uncertainty in the measurement will be half. Uncertainty will be the half of resolution. So the percentage uncertainty with the micrometer will be very low. Is it clear, this one? So uncertainty in the instrument is a half of resolution. The next is student determine the volume of a plastic protector from a measurement as shown. Show that the V, so you just have to substitute. Now student record the student recorded the following measurement. Like this is D is given. This is equals to half of D. X is given. And thickness is also given. I need the volume of this protector. So how to work out the volume? You can use, look, this part is there, which is a rectangle, okay? And this part is there, which is a semicircle. What is the volume of the circle? Volume of a circle is 4 by 3 pi r cube. What is the volume of the semicircle? So volume of the semicircle, it's the same. In terms of diameter, we can also work out. So if you like, this is a diameter. This is a total diameter of this. Okay. And what about what else I can do? Look, I will find the area of the semicircle because it's a 2D figure. I will find the area of the rectangle, which is also a 2D figure. And these areas, if area of a rectangle semicircle multiply by thickness, and area of a rectangle multiply by thickness, so I'll get the volume of the semicircle and I'll get the volume of the rectangle as well. Because it's like, if I know the area and I multiply by thickness, because if I draw a 3D image of this, so how it will look like there will be a rectangle, this will be a rectangle, and this thickness is there. Like it has a thickness T. So if I work out the area of this, area of the surface, and I multiply by thickness, what I will get? I will get the volume of this. Same thing if I draw a 3D semicircle. So this thickness is there. It has some thickness, and I work out the area of the semicircle. If I work out the area of a semicircle and multiply by the thickness, what I will get? I will get its volume. So an area of a circle is pi r square. If you have a circle, it is pi r square. Okay. And in terms of a diameter, radius is half of a diameter. So it will be pi d by 2 whole square. So this will become pi d square by 4. And then because this is for circle, but it is a semicircle. So I will divide by 2. The total area will be divided by 2. So if I divide both by 2, I'll get the area of the semicircle. So what is the formula for area of semicircle? It will be pi d square by 8. That is the area of the semicircle. So I'll get it here. And I will multiply by the thickness, so I'll get the volume. And what about the rectangle? For this part of a rectangle, length multiplied by width, so it will d multiply by x. That will give us the area. And then I'll multiply by the thickness, so I'll get the volume. And keep one thing in mind. Look, if you see, this is in centimeter, this one is in millimeter. All should be in same unit. We want in centimeter cube, so I have to convert x and d into centimeter as well. Is it clear how we'll work out the volume? Then we just have to add them. Yes, that's right.